Hello, everyone, and welcome to this Ask Tom office hours. Today will be a little different. We have a superstar, Chris Saxon, here.
Hi.
He is normally our evangelist for SQL and other Oracle features, but today he is the nerd who wants to do everything in JSON. And I am the conventional, everything needs to be relational guy. And we do have a little conversation here that starts out with like JSON or relational, and let's see where this goes, if JSON and relational remains opposite forces or if they can join for the common good. And with this, let's get the show started. I should put on a hat now and look old. I forgot to buy one. So
yeah, I shaved my beard off, unfortunately, earlier. So, but yeah, I mean, let's
okay. Let's get going.
So as we need to get started, you were talking about your high school a second ago. We've been asked to kind of help out, as you know. I'm sure you're all aware. People are having to do all sorts of remote learning and things virtually these days, and some people are perhaps a bit late to the scene. But we've been asked to come along and create some apps to help schools support online classes. So we need to build this app, and I started, building out the JavaScript classes. So we've got students, classes, and teachers, and we need to kind of manage the scheduling of them so we know who's teaching what and who's taking what. So I started with these classes, but I know how much you love an ERD data and see the entity relationship diagram. So let's just kind of walk through that and show what's going on here. So fairly obviously, we've got people who are taking these classes and who are teaching them, students and the teachers. And students can take many classes, and each class hopefully has many students. So there's a many-to-many relationship there. And there's also a many-to-many relationship from teachers to classes as well. One class could have many teachers. So it's like many-to-many all over the place. And we've just got these three entities are the ones we need to worry about. So I was thinking about how we can actually store this in the database. And I did what, every cool developer does these days. And I started Googling around, right? You just search for this. And I stumbled across this paper by someone who called themselves the Apollo Group, right? And they came up with this concept. They, in fact, modeled this scenario. People are taking classes and teachers are teaching them. And they did that using JSON. So you've probably not heard of what JSON is, right, Beta?
No. I'm just learning Java, this new programming language these days.
Yeah. So
still better in Fortran and COBOL. Yeah. Go ahead.
Okay. All right. So, well, the nice thing about JSON is it's actually very simple. It's a really lightweight format, and really there's only kind of two things you need to worry about. We got objects, which are a series of key value pairs, and there's arrays, which is an ordered list of values. And the main difference between them is the objects have the curly braces and arrays have the square braces. So what we can do is model a class like this, or the class someone's taking. So we've got our student here, Rick Martin, and we can see he's taking Introduction to Maths. So that's our object, and that contains all the information about this particular student. And the great thing about this from the application perspective is it's really, really easy. The code is dead simple. All we need to do is something like collection.insert, and there we go. We're done. But you're probably going to wonder about the SQL side of this, right, Beta?
Sure, show me the SQL.
Yeah, well, I started doing it, but it was like a page and a half long, and it's not quite finished. And I know you're talking about how we have to do bind variables and so on. This is a lot of code, and it's a lot of effort. Where I just like one line collection.insert, so much easier to build the app. We can get up and running, and it's also much easier if we want to fetch details as well. We want to find all the classes or all the information for a particular student. Just do collection.find. Again, nice and easy. And if we look at the SQL or the relational approach, again, we've got lots of prepared statements and all our bind variables and so on and so forth. It's just lots and lots of code. So I think this is really the way to go here, because it's going to make building this app nice and easy, and we can get up and running nice and quickly. Simple, right? What do you think, Beta?
Well. I'm not sure I'm really convinced here, because this reminds me of something. Let me look at the back at these old machines I inherited. I also have to now manage this old park here. Let me give you a little history lesson, but let's not look at the code, because the code really looks easy. Let's look at this data model exactly. Like pull up the record you show, and you probably stored more than one record. So let's just look at two. Yeah, you pull them up. Great. So you have two students here, Sally and Rick. And they both take this math course, right? But what you do, instead of in the relational world where you link your students to, let's say, a course table, you embed all this information. And by this embedding, you need to repeat it. So see how all the information on your math course is getting repeated. So what do you do if you do an update? So if you do an update, well, first of all, you can't directly update it. You have to kind of walk to your course data. And this update is probably a bit more complex, I guess. And since you have to repeat your data, you might also get inconsistencies, right? What if you update just one course for Rick, but not for Sally? Then Sally shows up later or earlier. And does your system that you propose there even have like proper transactions? Like instead of one update, now you have to walk through every student to update it. And also, I believe there is so this is a hierarchical data model, right? So you see that everything looks like being modeled under your student. I don't know how a teacher is there, but it says role is student. I guess there could also be a teacher. Yep. So you really have data dependency here. Like how could a course exist that does not have a student or a teacher? Let's say you want to give like a new course, Math 6. You don't have a teacher yet, you don't have a student yet. How do you put this into your system? And then even if you want to query your data, let's say you want to find all the teachers of a student or all the students of a teacher, like how do you do this? And let me tell you something, this looks a lot like IMS. This was a system developed by IBM long time ago. I was just finishing school then, but you were probably planned at this point, right? And this is the example here. If you go back one slide, this is the example from an old IBM documentation, like decades old. See where it has the course as the parent, and underneath it has the student and the grades, and underneath it has instructor and report. So you see the very same hierarchy that you have implicitly in your JSON. I mean, your JSON doesn't say it's hierarchical, but the structure is hierarchical. And you know where this comes from? This comes from all the way back from the Apollo program. So when they wanted to build this moon rocket, I mean, what did we just celebrate? 50 years of moon rockets. So this is how far this goes back. And 50 years on the moon means they built it even like a decade earlier. So when they built this rocket, they had to manage all these bazillion of parts. And these parts and subparts, they formed a hierarchy, right? Your Saturn V contained of multiple stage, and this stage contained of multiple parts, and these parts of subparts. So this was really a hierarchical problem, and they came up with a hierarchical solution, which was IMS. And now JSON, I tell you, looks and smells a lot like this. And because it's a hierarchy, how do you even deal like with M-to-N relationships? You pointed it out in your initial ER diagram that students and courses, et cetera, have an M-to-M relationship. So while you were giving this great introduction, I watched a few YouTube videos on this product and looked at M-to-N relationships. And what I found here is, for example, books and authors also form an end-to-end relationship, right? An author can write more than one book, at least if they're not totally unsuccessful. And some books have more than one author. And you see what they do. They basically use your JSON arrays, and they have like pointers in both directions. But what is really enforcing the referential integrity, right? What if you have a book that points to the author, but the author doesn't point back to the book, right? So you could have like a lot of nightmares if your data is not consistent. Your application will break, and someone calls you and says, I don't see my data, this is all wrong. And then you can look into your JSON arrays and check if these values are correct or not. No.
All right. Okay. So you're saying this isn't as modern as I thought it was. We're actually like
no. This is like a time travel, right? You go 50 years back into the past, and just because you weren't born then, you don't know that it's a time travel.
All right. Okay. All right. I think you make some pretty strong arguments there. But you know, I like doing my JSON stuff. What are you suggesting we do instead here?
Oh, we do what we do since 3 or 4 decades. We just go relational all the way. We create a table for students. We find out all the attributes. What are the primary key, the data types, how big the data types need to be, primary key, foreign key relationship, referential integrity constraints, and so on. I mean, we just need to do it right from the beginning, hopefully. So we start with a business analysis now. We have to do schema design, find all these properties, ER diagrams, normalization. Do you know what a Boy Scout normal form is, by the way? You forgot, right? Yeah. It was not the third normal form, right? So we do this. This takes a bit of time, but maybe let's say early next year, we can start with first table creation and then insert the first data. So maybe in March, we can do the first UI, something like this. But now we have to go and do schema design, find out what people need.
All right. So
it's going to take some time, like maybe a little under a year before we're finally done.
I mean, I can see this is going to be some effort, but you're really saying we're not going to be ready till sometime next year? I mean, hopefully we won't even need to worry about this in a year's time, right? We can't wait. People are crying out for this kind of support now. We need to be able to react fast and quickly. And, you know, you make a great point. We do need to go and speak to the users, so the teachers, maybe some students as well. Maybe not too sure about that, but I know how much you love the ERDs, and I know how much the art department like their pretty pictures, but do you really think the art department are going to understand what an ERD is? I'm not convinced, right? What they really want to do, they want to see the user interface. They want to look at it, and they'll, you know, come up with how they want it, all the buttons to go, where the buttons want to go, and how it all fits together. And of course, you know what happens as soon as you show users your application. They change their mind, right? They come up with some new requirements that they didn't have before, or they say, actually, that's not relevant. So, you know, we do all this work, and then you say you're on leave for a month. There's going to be all these changes. How are we going to adapt and support while you're away? What are we going to do?
Okay, I think we got that covered. I mean, we know some attributes of these entities, right? We know that a course maybe has a name, and a teacher also has a name, and student all has a name, right? And they may have an ID and whatever. So we just add a bunch of extra attributes. Like we just throw in like 10 number attributes, 20 string attributes, some timestamps. And if people later decide that they want the color of the course or whatever, we just use extra VC attr 29 for that.
I mean, okay. I mean, I guess that would work, right? But I'm really not convinced that's better than JSON, right? I mean, okay, yeah, we can put what we want in there, but how do we know what's in there? We'll probably have to come up with some extensive documentation or conventions about what we put in there, or we just don't know what we're retrieving. At least with JSON, you can got named attributes, right? And I mean, as you say, we could create a lot of these, but it's quite likely we'll run out of some, particularly particular data types. You know, what happens if I know you're telling us to use the correct data types and so on. What if we run out of timestamps or dates? And then what about constraints as well, particularly foreign keys? I know you're saying they're important. I don't see how they would work with this. And perhaps actually, the toughest thing, we've been talking about many-to-many relationships and things like this. How do we change the cardinality of the relationship here? Say we identify extra attributes which are in a one-to-many relationship. How do we do that? What do we do now? You know.
Yeah, you have a point there. You have a point. And you're arguing really hard to get your JSON database. But let me ask you this: like, I run already this zoo of machines here. Do you want to? And I don't need another machine with your JSON database on there. Like, will you be on the call if there is something broken on the weekend, 3 a.m. in the morning?
Of course not. And like 3 a.m. on a Saturday, I'm out partying, right? I'm busy. There's no way I'm going to be on call.
Yeah, and you expect me to do all this patching, and if there's security things, like who's going to do that? It's all dumped on me, or?
Sharding, doesn't that fix everything, right? I heard that solves all problems.
Sharding is for scaling. That has little to do with security or patching. So yeah, okay, that's another lesson here.
All right, okay. Well, I think we're both learning things here, right? But so what are you proposing we do here then? I mean, like, I'm not going to support another database, and you raised some good points about patching and security.
So we're really stuck here, right? I want my relational, you want your JSON. I think we need some help. Let me call someone from Oracle. I recently got these smartphone things. So yeah, okay. Yeah, that might work. I just spoke with Maria, and she told me about something that's called a Converged database. So she told me that Oracle I didn't know that, can not only store tables, relational data, but also other data, among that actually JSON data. So it would be possible, for example, to combine this. So we can create a students table, a classes table. So basically map every entity to a table like you would do it in a classical relational schema design. But then you could say for those attributes that may change or that are optional or that you want to add as you go, you could add those as JSON into the same table. See, look at this.
Okay. All right. I think this is starting to get somewhere, and I think that's a neat idea. We can get some of the JSON, but I think that's using this JSON for the flex fields instead of all those extra columns. That's a good idea. But I still want like a JSON API here, right? I just want collection.get and collection.put or insert and that kind of thing. How do I get? We still need to combine that relational stuff into a JSON document, right? How do we do that?
So you want basically to combine the relational data and the JSON data back into one big JSON object or array, correct?
Correct, that's it.
Right, yeah. Just look at the JSON developer guide. They have JSON generation functions that do exactly this. So you have functions that generate an array or an object, and you have aggregate variants of this. That probably I need to explain to you.
Yeah, go on.
So if you have your, so basically any array function, whether it's ag or not, generates an array. Any object function generates an object, if it's whether it's an aggregate or not. So what is this fancy aggregate? If you have a non-aggregate function, it basically converts every single row into a individual or separate array or object. But the moment you have an aggregate function, it combines all the rows that are selected in one aggregate. So you basically combine many values or many rows into one aggregate. And I can also give you an example.
Oh, cool. Okay, go on.
So let's say you have your teachers table and you want to convert that to an object. So there's obviously some relational fields like ID and name. And let's say we want to select all of them. So we use the star, JSON object of star means like generate me an object with all the fields from teachers. And you see that the column name becomes a field name, TID or first name, and then you have the corresponding value in your JSON as well. Exactly.
Okay. If you got a more complicated example, I think, this is nice, but we might need.
Yeah, I think I got one. Let's say you wanted to have all the teachers with the courses that they teach. So you would issue a query from your teachers table and courses table. So this is now classic SQL. I know that you have a hard time with this, so I'm trying my best to explain it. So you have a where condition in the where clause where you say I'm joining my teachers and course table based on the ID, and I group it by the first name and last name. And then you see in this object ag, I build a key, which is the teacher's name, and combined from the first name and last name. And the corresponding value is now a list of all the courses. So here you see how object ag and array ag can really be combined, and it doesn't have to be the ag function. And the result is basically one large object where the teacher's name is a field name. So you see Jean Kranz, And the corresponding value is a list of all the courses that Gene is teaching. Mm-hmm. That wasn't too complex, right? So if you want some JSON view over some relational query or some relational table, I think we can get this done using this JSON generation. But what I haven't really figured out is how can I do any reporting on this JSON?
Okay, yeah, that's a good question. So okay, we might need to think about this SQL a little bit, but you're right, it's possible. We can do some cool things there. So I've gone away and read the developer's guide like you recommended and found there's also these JSON kind of extraction or manipulation functions. So we've stored the JSON in a column, and what we can do is then pull out individual bits of it with these JSON functions. So JSON value, query, and table, and dot notation. And these are all kind of similar, but with JSON value, we're saying we want to pull out a specific attribute. So, you know, a number, a date, a string, that kind of thing. Whereas query, we're returning a whole JSON object or a whole JSON array. And we probably, as you say, we want to do some reporting. I know we've got all those BI tools out there which still talk SQL and so on. They probably want to convert this JSON data into like rows and columns and things like that, right? We can do that with JSON table. That does the conversion for us. And dot notation is just a nice kind of lightweight way to pull these things out and see what's going on. So I'll show you some examples here. So let's keep it kind of simple for this. We've got some courses here, you know, aerospace engineering and so on. And in our flex field, we're storing some extra attributes. So we can pull out, you know, the max students or the array of languages that this course is taught in. And with dot notation, it's actually just really nice and easy. We just have like the table alias, the column name, and then the attribute we want to pull out, right? So I think this is pretty neat. I mean, very easy, very intuitive, although it is a bit tricky with this array, right? We don't know necessarily how many languages they're going to be. We'd have to have, you know, what happens if like there's 5 languages one course is taught in? We'll have to keep changing our SQL query. So we can use our nested syntax here, which is JSON table under the covers, really, to do that conversion for us and pull it all out and see how it works. So we've seen some different examples here. We can go from relational to JSON or JSON.
Nice. Yeah, it looks like you familiarized yourself quite a bit with SQL now. I didn't know that. Like, compliments, great, good, good.
Well, I think.
So
go on.
Is there something you could show me, like these example, like what results they generate and so on?
Yeah, I think this would be a good point to actually have a little demo, actually, because we can actually use the always free Autonomous JSON service on Oracle Cloud, and you know, this is free forever. Do what we want. So I think this is a great environment to try things out and actually do a little demo of how this all fits together. So I think this is cool. We've got I've got my a cloud account here, and you see these are always free. I've got my transaction processing and my JSON one. You can create one nice and quick to set up, although, you know, even as quick as it is, we don't want to sit around for a minute or two watching me click through some screens. So I've pre-created it for us, and we can then, by going to the database actions tab here, so we just go into the information, open database actions, and then we will get be able to actually integrate it. We've got like SQL Developer Web, essentially. So this is an interface where we can write some SQL or some JSON and other things as well, and actually interact with a database. Okay, so if we go over here, so up on the top left here on our development, we've got SQL execute queries. That sounds like what we want to do here, right, Beta?
Yep, let's do some SQL. So this is an Oracle database, although it's called Autonomous JSON Database, it is still good old relational machine underneath, right?
Yes, it is good old relational machine underneath. And we'll start with some just classic relational stuff, because I know that will make you nice and comfortable, right? Yeah. Okay, so we'll start off with just a basic teachers table, and this is just a standard SQL. So we'll run that, and we'll stick a couple of rows in there. So we've got Neil Armstrong, Gene Kranz. Let's just hide that a bit, so we've got a bit more space over here. And then, as you said, to kind of make the JSON, we can just do the star operation, JSON object, and that will just pull it all out and generate the attributes and their values from the column names. So that's pretty nice, but you know, it's just using the column names, right? We probably want to change those in some cases. So we want a bit more control. We can actually JSON object it, give them, you know, they, instead of these underscores, I don't like those underscores in JSON. We want like camel case names, right?
Yes, exactly. Yes.
We want our camel case, so we can rename them and pass an expression in here as well. So we can do things like combine the first and last name. And there we go. We've got a more structured JSON document, or more control over what it is. And we can then even format this into an array. So before, with JSON objects, we had two separate rows. By array agging them, we will combine them into a one document. And you can see, actually, I've used a subquery to kind of give the column aliases and things like that. So we can then use the JSON object star in another way as well. It just uses the actual column aliases. So whichever you're more comfortable with here, right? So,
nice. Yeah, I like the with clause. It's very usable to modularize things. Yes.
Exactly, and then it makes it easier to break up, particularly if you've got big statements, which certainly can happen if you've got like complex JSON that you're trying to generate.
Yeah.
So that's all right. So let's start bringing some more JSON in here. So let's create our courses with our flex field. This uses the JSON data type. So this is a new data type that's come in the latest release of Oracle Database 21C. So I think let's take advantage of this, and we can.
So here you mix JSON and relational fields. So this is like a hybrid storage model, basically.
Exactly. Well, it's like you say, there's some things we definitely know a course has. We know it's got a name. We know it's got, you know, we're just having a one teacher on this one and start and end names. There's always going to be some attributes that you know everything has, right? So we can do that, and then we can have our flex fields with these students and things like that. So let's just create that table and insert the data, and there we go. We can see we've got some objects, some without, and so on. But
oh, it's not showing the JSON, it's just saying object.
Well, because this is like, it's kind of an internal, it's an optimized JSON format. It's not just storing it as text, right? So it's when we retrieve it, we can do some manipulation of it to convert it back to text. There's a little JSON serialize function which will convert it back to CLOB or whatever other data type.
Okay, so they store it in a more efficient binary manner to avoid parsing. So it basically makes it faster, I guess.
Yeah, I understand there's some pretty good performance figures on how this can really help, because, you know, if you imagine you've got a massive JSON object and it's just text, parsing that can be slow. So, but we can pretty easily convert it back to some nice textual relation.
There it is. I can see it. Max students.
Student. There we go. And we can have the little pretty as well, right? Pretty option. Okay, so we can pull that out, but we can also use, like I said, we can use the dot notation to pull out individual attributes, such as, we'll just get the max students here. It's taking a second or so. You can see now it's kind of subtle, this, and it's not particularly obvious, but you see how the numbers are kind of like left aligned here. That means that they're actually, it's returning them as strings, right? It's returning them as a varchar, which you're always mentioning like these implicit conversions, and we should watch out for them and how they're evil and can cause all sorts of, you know, nasty things to happen. So we can actually use, there's all these methods with dot notation as well to things like specify the data type. So we can tell it that these are numbers, and I'll pull out the fields from the array as well. And if we run that, then you should see that everything is like
a number.
Yeah, there we go. Yep, nicely right aligned, and we pulled out our things.
And I see if a value is missing, you just get a null value back, basically. It's not an error.
Yeah, exactly. Exactly. Although that's an interesting point. We'll come back to that in a second, right? So, but what I want to do really here is we've got English and Spanish as separate rows, but what happens when we add German and French and Japanese and whatever, right? We want those as rows, so we can do this.
Yeah, it would be hard to write a query that looks for language 1 as this, or language 2, or language 3. Okay, how did you solve this now? Now I see it's different rows.
Yeah, so you can see we've got this little nested syntax, which is saying basically it's got an array within it, and pull each element of that and generate a row in the output. So that's pretty neat, right?
Okay. So it's this nested on the language, and I guess the star means for every language. Okay, and it repeats the value for that are outside because they apply to the same language, like improvising space repairs is being taught in English and Spanish. So this is why you see it twice. And this is why I guess the number of rows is now also bigger than your number of courses, I guess. Yeah.
Exactly. Yeah.
Yeah.
So, yeah.
Makes sense. Makes sense.
Yeah, it's good, right? Now, you were mentioning earlier about these nulls and how it just kind of merrily keeps going and we get result. Now, there might be some point where we kind of go, actually, we want to know if like which language a course is taught in is missing, because maybe we decide that that's important, or we want to throw an error if something is not present. And we can actually, there's a whole bunch of options here for what to do if the JSON doesn't conform to what you hope it does, right? Yeah. So in this case, we're saying if it's empty, if it's not there, then it will throw an error, and this will just give us an exception. So, in some cases that could be quite useful, right? We can
you can enforce that the data has some fields, I guess.
Yeah, I mean, you might even be able to use this for some kind of constraints and stuff as well, maybe. If you're feeling really get your relational head on, right?
you could add a check constraint that says this one has the field A, B, and C, etc. Yes, that's right.
Okay, so let's start then turning some of this relational stuff into JSON a bit more. We'll start off with just the basic SQL query to make it a bit easier to see what's going on. So we're getting our names and what courses they teach. And we
classical join with two tables, exactly, yes.
Exactly. So what we want to do is make that document you showed where these names are the keys in the JSON object, right?
Right, yeah.
So we kind of pass that expression in as the key, at the value, and it's got that join. And if we run this, got the pretty option there as well, so it looks a bit nicer. There we go. Nice. We can see.
Yep.
That's looking pretty cool, right? Okay, so that's kind of sticking mostly in the relational world, right? So, and I think people who, I'm sure you with your SQL experience are quite comfortable at this point, right? So let's move on and do something a little bit different. We're going to use Soda.
What's this?
Well, this is simple Oracle document access, and it gives a NoSQL-like type of API for actually interacting with the database. So this is where Autonomous JSON is a little bit more than just a relational database, right? We've also got this nice Soda API. So we're going to create our collection. We'll call it students. And then we can just put our JSON objects in there. And we can run those, and they're fairly straightforward.
Hey, how do I define all the field names and data types and all that? Where is that part?
Well, it's just JSON, right? So, we use the properties of the JSON, and we're just saying, JSON has the basic data types of number.
Oh, you're saying this is just a bag of JSONs, basically, and you give that bag a name, in this case, students. Okay.
Yeah. And it's kind of up to us, really, to make sure that we are, in fact, sticking student records here and not kind of, teachers or some other nonsense. So it is just a bag of JSON, like you say. But it's really easy, right? We just do these inserts. We can get them with the Soda get.
That's what you liked, right? This was your first introduction, why you liked it in the first place, these simple APIs.
Exactly. So nice, simple APIs. We can do get everything. So we see that. Now this is looking a bit kind of cryptic at this point, right? But fortunately, we can see a bit more. So we're going to do a kind of search here. So we've got ID2. So hopefully we're going to find Catherine Roberts here when we run this. And we get that back. It takes a second or so. And there we go. So we can see, there we go.
Okay.
You can see that key is just like an internal GUID key, right?
Okay, so this is your key value store, kind of, yeah.
Exactly. And we can actually even do some more interesting searches. So courses is an array or not, depending on what we've actually stored there. We'll find everyone who's taking course C1, whatever that happens to be. And we pull that back. And you can see even though in some cases it's array and sometimes it's a scalar, or selecting those the wrong way around, but hopefully you get the idea. It still can return both of them. It just says, does this value exist anywhere within that attribute, essentially?
Yes. Okay, got it. So these are very easy filters, basically.
Yeah. This is nice. I think this is great from an API, keeping it simple perspective. But I think the bit that you're probably going to really like is that actually under the covers, it is actually just a table, right? It is a database table.
Oh, your soda collection is just a table. Got it. Okay.
Yeah.
And
So
there is JSON. Yes. Okay. Created on.
Lots of metadata about it, and there's the actual object itself. And if we do that JSON serialize we were looking at earlier, we should actually see what the contents of them are. There we go.
Okay, just the regular from clause, so I could even issue SQL queries over this, I guess, then.
Exactly. So we can do something similar to what we did with the courses with the languages, where we had the nested syntax. We can pull out and see which courses people are taking, and there we go. These people are taking these courses. So this is nice, right?
Yeah, this is nice.
And we can even then go a bit further and convert to it, if I can actually select the thing. As we were saying, using this with clause to kind of break it up. So that's what we had a second ago to turn it into a relational view. We can then join it to all our existing.
So what is this query doing? What is this query doing? Like, what is the purpose of this query? Scroll up again. So this is saying.
So what we want to find all the teachers for a particular student.
So this was the query that was super hard on your, like when you demoed when you gave this JSON example, this is where I ask you, this is the query that would be quite hard to run if you didn't have SQL, right? Got it. Yeah.
Yeah,
okay.
This is the thing we were saying where basically we have to kind of go down the hierarchy.
Yes,
and back up
or maybe even write your own code to do the join there. Yes.
Exactly.
Yeah,
that would have been. So what we've done is we've kind of taken the bits we've done before. So we have this to split out the courses for a student from the pure JSON to a relational view. Now we use our with clause to kind of encapsulate that logic slightly, and then we just join in the teachers and so on as we do that. And we're looking for which courses Bjarni takes. So we can do standard filtering, and we run this. I can just get it all selected. And here we go. He's being taught by Gene Krantz. There we go. So pretty straightforward. It's just, 14 lines of SQL. Nice, right?
Okay.
Yeah, I think.
No. Okay, so now we know all the teachers by the student. Yeah, okay. This is just the join. Yeah, that's great. So you must like this now, right? SQL, it looks like you're a big SQL friend by now.
Yeah, I'm picking it up. It's actually not that much to SQL, really, is it? Once you start playing with it.
Yeah, that's right. That's right. Good. Perfect. Now this kind of really shows us how you can combine it, right? So this is, and this was an autonomous JSON database you were saying. So can I only run this on this database, or because I'm not sure I have one sitting in the back there.
Well, I mean, you can use this JSON functionality in standard Oracle database as well. So if you're running your on-premises databases, or you've got cloud DBCS services and things like that, this JSON functionality is all there. I mean, all that SQL stuff is built into the database, so it doesn't matter which version you're using, right? You can
okay.
Yeah, but there's some.
So this old version 8 that doesn't have it, right? So
no, I mean that might even be older than me, right? Version 8. I mean, if anyone's running that, surely I don't know.
Yeah, they keep bugging me about upgrades, but I ignore them. It's running. Never touch a running system, I say. Now, what version do I need at least to run this?
So the JSON stuff was introduced in 12, and it's one of those things that just keeps incremental additions in each extra version. So anything from 12C onwards, you will have some of these options.
Okay, good. Sounds like I need to upgrade then.
Yes, it's time to upgrade, right? You can replace some of those machines behind you while you're at it. You can probably get things that are a bit smaller, right?
Yeah.
All right. So I think some people might be wondering as well, what kind of like the difference between the various autonomous services we got? Because we saw I was using like the free autonomous JSON service, and I mentioned there's a free ATP and things. It's like, how do these compare to all these other ones? So as I said, the free stuff is free forever, but it is limited in your capacity. So, and this applies to whichever of the free autonomous services you use, limited to 20 gigs of user data, and you can have 2 databases which have 1 OCPU to each. The great thing about these is they are free, completely free, right? Who doesn't love free? But you can then also either, if you know you're going to be building a big system to start with, or you can upgrade these if you start off with free to autonomous JSON or autonomous transaction processing, and they allow you to use as much as you're willing to pay for, pretty much. The big difference with autonomous JSON is it is quite a bit cheaper, like a quarter of the price of full ATP, but it is limited in terms of your relational storage. So those soda access, we can have as much as we want, but we can only have 20 gigs of relational data. So, I mean, you know, I think
then probably AJD is good enough for us.
Yeah, I think so. I mean, I think, you know, 20 gigs is actually quite a lot of relational data, really, particularly if we're going to be using those JSON flex fields, right? So,
yes.
So what do you think, Beta? You
happy? That's good. I mean, overall, I really like that we converged here. So initially, I thought this will be a this will be a hard fight, and it was about who wins over whom. Is it relational or JSON? But now I think we can actually combine these 2 data models and use the strength of each model so that overall we got a stronger system. So I think if you allow me to recap this, I think I convinced you a bit that normalizations and schema still matters. We don't want to mix different entities like students and teachers and courses all into one big hierarchy. That would be really going on a time travel 60 years back to IMS. So we still do normalization, but where it makes sense, for example, if we need schema flexibility, where we want to add attributes quickly on the fly, we would use JSON to do that. So we could easily add a field in the UI and map that to the JSON and make application changes without having to do database schema changes, no alter table add column, basically, no downtime, no synchronization between application query change and database schema changes. This is really good. And there may be some cases where we say, hey, let's only use JSON. This is your soda case where you say, I don't want to deal with a table that may have some relational columns and some JSON columns. Instead, my mental model is really like a bag of JSON data, and that bag has a name and it's called collection. And if I do it this way, I have also these easy APIs, these simple puts and gets and filters where I don't have to write any SQL at all. So this is probably something that people who come with a document store background or NoSQL background would prefer. But then at the same time, we could do reporting over this just using SQL, because at the end, it is still a table. So I believe it's really not at all a this versus that, but actually we can combine it. It's really to the mutual benefit if we combine relational and JSON. Yeah, this is good. Hey, let's celebrate that we came to a good solution here, and I'll buy you a beer or 2.
Oh, I'm happy with that. You're buying me a beer? That must be a first.
Yeah, that happens very rarely. You can mark it in your calendar. Yeah.
Yeah. Okay. I'll frame it, right. You know, I'll get the receipt.
I assume you're old enough, but.
Yeah. Well, I might need to get my ID, right. You know.
Great.
Okay. All right. And for anyone who wants to follow up on this a bit more, so we've got some various links to sign up for the free autonomous service. You can just cloud.oracle.com free. I've got a massive article talking about how to work with JSON in Oracle Database. And we don't have quite the scripts in this post that we've used today, but something very similar on LiveSQL. So if you want a very similar demo, if you follow this link at the bottom, that takes you to LiveSQL, and that shows you something very along the same lines. So,
right. And we also have a live labs. The link is not on here, but there is Oracle Live Labs where we have actually labs, and there is one on JSON and SODA as well. So if you go to Oracle Live Labs and just query for SODA or JSON, you would see a very similar lab that where you can follow what we did here.
Oh, that's great. I think I'll add
even
that.
A bit beyond that, yes.
Yeah, I'll add that to the links because when we post the recording, we can add the links so that people.
Actually, that's a good idea. That's a good idea. So there's a couple of questions here. Chris, are you okay if we go to the questions?
Yeah, yeah, sounds good.
So I can take a few ones. So there is one from, okay, we're not supposed to mention the name, but there's one that says how to play DML on a JSON array, like insert, update, and remove without the index. So with index, he probably means the position in the array. So they have a value in an array, and they want to remove this value without knowing the index position. Exactly. So there is an update operator called JSON transform, and that has also been backported to version 19. So I earlier asked the question what database I would need to upgrade to have this capability. So it's 12.102 at a minimum, but I would highly recommend to use a 19C database. And if you have 19 C, the patch set 10, like 19.10, you get JSON transform. And there you can use predicates. So you can say, I want to remove all the items in that array that, for example, have the value 4, 5, 6. So this is one way how you could do it. There is also on earlier versions, if you want to do modifications on JSON data and you cannot express this in SQL, there is also a PL SQL way. So PL SQL is always a fallback where you can programmatically convert your JSON into a in-memory modifiable tree structure, and then you can walk that, add nodes, remove nodes, etc. It's a bit more cumbersome because you write code to it, but it would be possible. There's also an update operator called JSON merge patch, which is also, I think this was there since 19, even the first version, that allows you to do updates on objects. So this is implementing the merge patch RFC, but that is quite weak on arrays, so you could not make any arrays replacement. So I spoke a lot. Short answer would be look at JSON transform and predicates. There's one other question here where it asks, is joining data bad? With JSON, I don't need to join. I get all my data in one record. That's actually an excellent question. I love this one. And this is true and false at the same point. So if your use case is such that you typically have to reassemble an entire business object before you can work with it, then storing it that way may be beneficial. So I give you one example. Let's say you write an online game and there is a game state, like what money do you have, what sorts, where are you, etc. Right? So this could be a quite complex object, and it would be composed of many different entities, many different things. So if you would map this to a relational structure, you may say, oh, my game state would actually map to 50 different tables. And most likely I would need to join all these 50 tables to get a usable business object out of it. That would be a classical case where you store JSON, just because during insert, otherwise you would have to shred your data into 50 tables, do 50 inserts, and during a get operation, let's say get game state for user Chris, you would have to join all these 50 tables again. So yeah, JSON would be highly beneficial. And we actually see this in real life. We have customers, for example, a very large shipping company who stores all the information about the package status as a JSON. And they actually saw quite good query performance improvement by replacing 20-something tables with one JSON. But this is not like always true. So let's say these entities that are being joined have also their own existence. So let's say you have this student, well, student teacher, right? You could merge them, but very often you have operations on teachers or you have operations on students, right? It's as likely that you go into one of these tables that have one of these entities. Like if you merge them, then you have to kind of unmerge them if you want to do updates on those. So this is what we said on these earlier slides, that schema design still matters, like identify your entities. Does it really make sense to mix many entities in one? So like a student is not a teacher. So if you mix them, yeah, you may not need joins for some operations, but then for many others, you kind of have mixed your data and you need to untangle it. The other thing you could really do in Oracle, as it is a relational system. So let's say you store your data. Let's say you store your data in tables, but often you need a JSON representation of it. So what you could do is you could do a materialized view. So over your relational data, you specify a materialized view. And if something, then you have quick access to every different entity in its own table. But if you make an update, the materialized view would get refreshed. We have also different refresh options, including fast refresh. Then the JSON would be rebuilt. And if you have a query that needs the JSON version or like the joined version of this, you would not build it on the fly. Instead, it's already pre-built and sitting in the materialized view, and you could just pull it out. Okay.
That's a great point, Beta. I think because it's worth remembering, if you've got all the other toys and tricks available in Oracle database to do things like materialized views. So,
exactly,
you know, you've got the trade-off of thinking about what your use case is and what you're doing, but it's also being aware that there are things which can solve the problem in perhaps a different way than just a straight join. You know, it's not always just full JSON versus full relational. There are lots of things in between.
Yeah. I think we need to add a bit of update to this demo, Chris. There's another question for an array having objects. Is adding, deleting objects in the array possible? Absolutely. Again, please look at JSON transform. And I might have added something on Live SQL, but just if you don't find a good example, just email me or ping me on Twitter and I try to find out something. But the answer there would also be look at JSON transform.
Yeah, there's a lot of options with JSON transform. It's very cool, and certainly stay tuned because we will make some demos and examples of that, how that works.
There's one question on the Express Edition 21C. Do you know when that is supposed to be out? Are we allowed to talk about it?
I'll just say very soon, right?
Okay.
Very, very soon. Okay. Gold on, you won't be waiting too much longer.
Right. Another question on JSON transform, detailed documentation. Yes, absolutely. It's documented. It is definitely in the 21C book. So just Google for JSON transform or JSON transform Oracle. And we basically have it in two books. It's in the SQL reference that gives you a syntax diagram. And then there is this JSON developer guide that we also mentioned here that is also giving you some examples. So since we backported it to 19C, you may not find it in the 19C book yet, but it is definitely in the 21C in both books there. Good. Is there a question?
So we had a question about JSON object returns varchar 4000 by default, and they want to extend it beyond 4000. And can returning help in this scenario?
Yes. So basically, all these SQL JSON functions like JSON value, JSON query, JSON object, JSON array are able to return the result in different data types. So JSON value, for example, by default, as Chris has shown, returned these numbers as a string, but then he added these trailing functions number to convert it to a number. And there is also a returning clause where you could have said returning number to make the same change. So in order to not always have to type returning this, returning that, we pick the default, which is the varchar 4000. But you can always override that. So you can say, for example, this JSON object returns a CLOB or a JSON data type or a varchar of a bigger length than 4000. Yes, definitely.
So there's one. Here's an interesting one. Why is JSON serialize an implicit not? Why is JSON serialize not an implicit function? Let's Oracle store it optimized, but when someone queries and says it's a JSON data type, why can't it use JSON serialize and display the data?
I think what we saw here in your demo is it showed you the JSON as object, and I believe in a future version, for that user interface, we will actually print it, convert it on the fly to a text so that you can see it. But this would just be a user interface thing. In reality, you would want the JSON result, the JSON type, be shipped to your application code, because you don't want any conversion to happen on the database that takes CPU cycles. And as Chris said, this binary format is optimized for fast access. It means that we don't have to scan through the JSON text to find the value that you're interested in. So let's say you have a long JSON and there's one value in the middle, and let's say it's the name of a product, for example, and you would say .name to get the stuff. We can jump right at it. So now if we ship the JSON type to your client, let's say to your JDBC code, you can do the exact same on the client as well. If you would receive this as a text, then you basically have to, again, parse it on the client side. So this is why we don't do any implicit conversion, because there is good reasons to consume the JSON type as a JSON type on a client as well.
Okay, I think there's one last one I think we probably want to finish on, perhaps a bit of a provocative one. Surely all of this is just unnecessary overhead that slows everything needlessly.
I would say that might be true if you don't use it correctly. We see actually, I mean, this feature is out since 12.102. So this is several years now. What is it, 6 years or so? And we have quite a large number of customers also, like with very demanding workloads. I already mentioned this global shipping. It's actually one of the largest global logistics company that uses JSON for performance reasons, because it basically avoided joins in their case. A very strong driver to use JSON obviously is schema flexibility. So we have a large financial institution, to give another example, where they have attributes or metadata on financial products, and they may decide to have 3 new attributes tomorrow in their application. And it would be very hard to maintain a schema every day if new attributes show up. So with JSON, they gain the schema flexibility. Obviously, then, why would performance slow down? You can add indexes on it. You can do materialized views on it. Our JSON, a binary JSON format could almost be seen as another row format, which is very fast. So in general, I would not agree to that statement. But yes, you can definitely, if you create 2 massive JSONs, you don't put indexes on it, then yes, you can do something that is very slow. But I think you could do the same relationally if you force bad plans, or if you create schemas that are just not very good for your application. So I don't think this is really a JSON property.
I think
great. We're a bit over time already. I think this is a very good response from the audience regarding questions. So I hope to see you, or we hope to see you back next time.
Yes, that's great. Yes, thanks everyone. And I will see you all again soon.
Okay, bye.